integration questions. So let me solve guys. The first one is the integral, that is nothing but integration of root of 1 plus 2 cot x times of cosecant x plus cot x of dx, where your x lies between 0 and pi by 2. Then they ask us to find the value of this particular integral. Before going on to the question, people first try to understand. Actually, calculus part is a bit difficult for most of the people. Everyone says that calculus is difficult for me. For 12th standard people, calculus is difficult. That is what each and everyone say, okay? But if you practice more and more on this particular topic, calculus, either it can be your differentiation, integration, the practice is very important, okay? Practice something makes you people to do these kind of questions or tackle it in a faster way. Actually, for integration, we know now, for example, for one sum, I am using substitution method. Means what the thing that you guys need to get in your mind is the substitution. Nothing but for what expression I should take for a variable. That is the trick or the hack that you guys supposed to know, and that only comes when you solve a lot of questions, okay? When you solve a lot of questions, then definitely if you see an integral question, then of course you will know that the first methodology, the first trick, or the first what I should do. That is what you guys need to get in your mind, and for getting that, practice is important. Don't ever forget that. Now let us solve this question. So people, this is the integral given in the question. So first let me write this integral here. So integral is integral of 1 plus 2 cot x times of cosecant x plus of cot x then times of d. This is the integral we are having now. So people, what I am going to do here is just observe very carefully. I am just going to multiply this 2 cot x inside the bracket. I am going to take it inside the bracket. Therefore, this integral I can write it as root of 1 plus, when I take multiply, I get it as 2 cot x times of cosecant x, that is 2 cot x cosecant x, then plus of 2 cot x times of cot x, that is 2 cos square x, 2 cot square x. Then on the whole I will have dx. 1 minute people, 1 minute wait. So this is the sum we are having now. So actually I multiplied your 2 cot x inside the bracket such that this expression you guys will be left out. That is something but 1 plus 2 cot x times of cosecant x plus 2 cos square x of dx. So now after this what you will do is, listen to me very carefully. This same integral I can write it as, tell me, can't I write this 2 cot square x as cot square x plus cot square x? Can't I write like that? What is the reason behind writing like that? It's because I am having 1 here, and 1 plus cot square x, the form we will get 1 plus cot square x, using that form we can write it as cosecant square x. That is our main motto, and people never ever forget this, okay? Your first methodology or the first secret that you guys are supposed to know is, you need to write something using the identities or some formula that you guys already know. Because in any question you can't just directly go upon with it. It's not CBSE. In JEE Mains or JEE Advanced, you need to do some changes, and then only you will get the formula. You will get the formula in that particular equation or expression, and then you can go upon with it. Okay, so please understand it. So now I can write this cot square x as 1 plus cot square x, correct or not? Then I will put a bracket here, then plus of 2 cot x, then cosecant x plus of cot square x, correct or not? This is what you will get. We will get right when I write your 2 cot square x as cot square x plus cot square x, such that your 1 plus cot square x is what? Your 1 plus cot square x is nothing but cosecant square x, Pythagorean identity that you guys learned in your trigonometry. So let me write it as cosecant square of x. So this is what you guys will be left out into the square root of the integral. Okay, va? So now we can get the expression such that you can use your identities. Okay, so this looks like a form of a square plus 2ab plus b square. A square plus 2ab plus b square is nothing but a plus b whole square. Just use that and make the integral in a short form. Okay, so now we'll get it as integral of root of this integral, that is a square plus 2ab plus b square, that is cosecant square x and your cot square x. So your a is cosecant x and b is cot x, so that I can write it as a plus b whole square, that is cosecant x plus cot x the whole square. That is what will give us this particular expression. I'm just making it in a shorter way using your basic identity that you guys learned in your logarithms. Okay, va? Perfect. Everything fine. So that is what I'm doing here. So now here it's dx, and now we know the root of some square value. Of course, it is the value inside the square root. So that is cosecant x plus cot x times of dx. This is what you will be left out now. Correct or not? Just think carefully and say, people. I hope that is clear to you people. So just as I am having square root of some square value, of course you know, for example, square root of x square, if I am having, what many will say is mod of x. Correct or not? Square root of x value, x square, it will be mod of x. Right? But actually here for simplicity, I am just removing those square and root such that it will be left out with this particular expression, that is inside the square root by eliminating this particular 2 and 1 by 2. Okay, but actually this is perfect. This is what we should do, but for simplicity I am doing like this, guys. And never ever forget, root of x square is mod of x, not x. Don't do this mistake ever. Okay, because we don't know whether your x is positive or negative. For example, if I am having root of minus 7 square, if you say that your x value as the answer, then it will be minus 7 now, but it's not possible. That's why I am saying mod of x. Okay, so please understand that, guys. In this video, I am telling each and everything that you guys are supposed to note it. So now this same integral I can write it as, listen, contain it is cosecant x as what I can write, 1 by sin x, and same this cot x as cos x by sin x, contain write like this, then the whole dx. So I can write like this now, basic identities that you guys learned in your 10th standard. So cosecant x 1 by sin x, cot x is cos x by sin x, and now try to simplify it a lot, and then you will be getting the answer for sure. So this I can write as integral of, so we know sin x there, denominator is same, so 1 plus cos x by sin x the whole dx. Okay, so that is what we are having here. So correct now people, I hope that's perfect. So now what you can do is, think carefully what you can do. What you can do is, we know that your 1 plus cos x, that is a basic identity. Your 1 plus cos x can be written as 2 sin, okay, it's 1 minus cos x. 1 plus cos x can be written as 2 cos square x by 2. Very important, okay, don't ever forget this. And your 1 minus cos x can be written as 2 sin square x by 2. Okay, don't confuse with these two formulas. 1 plus cos x, 2 cos square x by 2. 1 minus cos x will be 2 sin square x by 2. So this same integral I can write it as integral of the denominator 1 plus cos x, I can write it as 2 cos square x by 2. Correct or not? And the same, the denominator I am having sin x. Just sin x. Listen to me very carefully. Can't I write the same sin x as sin of 2 times of x by 2? Think carefully and say, Can't I write the same sign x, sine of 2 times of x by 2, because your 2 into x by 2 is x only. So now let me use your double angle formula. Double angle formula, sine of 2 theta is 2 sin theta cos theta. Here theta is x by 2. So 2 sin x by 2 times of cos x by 2. Can't I write like this, people? Very, very simple formulas I am using here. So now this sin x is 2 sin x by 2 times of cos x by 2. So now just try to simplify it more and then you will arrive at the answer. Okay, so let me rub these things. So people, I will tell it once again. 1 plus cos x is 2 cos square x by 2, and your same sine of x can be written as 2 sin x by 2 into cos x by 2. Just I am using a double angle formula and making your x as x by 2, that is 2 times of x by 2. Please understand that. I hope everything is fine. So now just try to cancel it out. So 2 I can cancel, and 1 cos x by 2, and here it will be 1 cos x by 2. Just well, and I cancel it out. So now therefore I will get this integral of cos x by 2 by sin x by 2 times of dx. This is what you will get now. So now we know integral of cos of some value by sin of some value is cot of that value, that is cot of x by 2 times of dx. Now use a direct formula, that is integral of cot x, integral of cot x formula. So we know that your integral of cot x is nothing but ln of sin x plus some constant c. Okay, I think this is the formula. Integral of cot x is ln of sin x plus some constant c. That is the formula I am gonna use here. So now we know that your initial value is cot of x by 2, just the angle change. Therefore this will be nothing but ln of sine of x by 2, because the angle is x by 2 here, then plus some constant c, and this is the answer for this particular question. People, integral of cot x by 2 of times of dx, 1 minute wait, why I wrote 2 dx? Why I wrote it 2 times? Sorry, it's wrong. So cot of x by 2, so integral is ln of sine of x by 2, use this particular basic formula, but here your x is x by 2. Just try to change it up. So now let us move on to the next one. Our next question is, if integral of dx by x times of x power n plus 1 is equal to capital A times of log of x power n plus 1 by x power n, then plus beta, where your beta belongs to real numbers, then we have to find the value of a. So people, just try to understand, here your constant is beta. You may ask me something, hey man, actually every time they use this constant as capital C, why it's beta here? Guys, don't confuse anything here. Don't think beta has some other expression or integral, okay? It's just a constant, okay? These are the basic things that you guys are supposed to know whenever you read the question. Use your common or use your logic or use your common sense, okay? Then only you can get the question very well. So now, how we are going to solve this question? Just listen to me very carefully. In the LHS, I am having this particular integral now. I need to somehow make this integral in terms of this particular a log of something. That is what our main motive is. I need to make something to this integral, or I need to calculate the value of integral in terms of a times of log of something, so that I could find out the value of a. So now what I'm gonna do is, let me solve the LHS. That is integral of dx by x into x power n plus 1. This is what I am having now. So now what you're gonna do here, just listen to me very carefully. The denominator, I am having x times of x bar n plus 1. So this will be x times of x bar n plus 1. In this particular expression that is inside the bracket, I'm gonna take your exponent common. I'm gonna take your exponent common. This will be exponent times of 1 plus 1 by exponent. Correct or not? Think carefully and say, can't I write the same denominator as like this just by taking your exponent common? Think carefully and say, people, am I correct or am I right to do such things? Of course, it's right, okay? So now, when I take exponent, this is something you guys will be getting. So now the same integral I can write it as integral of dx by x into exponent. Use your laws of exponents. That is x power n plus 1 times of 1 plus 1 by exponent. And now think what we can do. Any idea for you people? So what you can do is I can use a substitution method because there is none other formula to use here. Substitution is the best way to simplify this question to a large extent. So now what substitution I can take is just take the expression inside the bracket as substitution, that is 1 plus 1 by exponent. Let me take it as t. Then what will be your dt? Your dt will be differentiation of this particular value of t, that is differentiation of 1 plus 1 by exponent. So now can't I write this particular t here? I will write it out here. 1 minute wait. So 1 plus 1 by exponent, when I try to differentiate it, the differentiation of the constant is 0 plus of differentiation of 1 by exponent. So 1 by exponent is x bar minus n. X bar minus n, differentiation of this particular, that is d by dx of x bar minus n will be x bar minus n, minus n times of x bar minus n minus 1. So I think I need to write it more legible, okay? I think it's not visible for people. So let me try it out once again. We know that your t is 1 plus 1 by exponent. Now our motive is to find out the value of dt just by differentiating this particular expression. So to differentiate this, just use your properties of differentiation. That is d by dx of some value, that is sum of two values, will be d by dx of the first function plus of d by dx of your second function. So d by dx of sum of two functions will be just differentiate each function and just add it up. So now we know that your one differentiation is 0. I have to find the value of differentiation 1 by exponent. I can write the same exponent as x bar minus n. So d by dx of x bar minus is something we need to find out. We know that your differentiation of exponent is nx times of nx power of n minus 1. So here your power is minus n, therefore I can take it like this. Then minus n times of x bar minus n minus 1. Can't I write like this, people? Think carefully and say. And now this same expression I write it as minus n times of x bar of minus n minus 1. In the power take minus common. That will be minus of n plus 1. So now the same expression I write it as minus n minus of n plus 1. Therefore I can take the denominator. That is x bar n plus 1. Okay. The basic things. I hope that's visible to you people. Of course it will be visible. So that's what you will be getting when you just differentiate that particular value. Okay people. So let me say what I did here. Just I differentiated your 1 plus 1 by exponent. Therefore this is the expression that will be left out here. So therefore I will write here. Minus n by what I got, x bar n plus 1 times of dx will be your dt. Correct or not, people? So this is the substitution I'm gonna use here. So now let me rub it out. So now just try to use a substitution in this integral. Therefore the same integral I write it as dx by 1 plus 1 by x bar n is t times of, listen to me very carefully. We have x bar n plus 1 in the denominator. But we know that your dt value is nothing but minus n by x bar n plus 1 times of dx. So therefore, if you need to get the value of x bar n plus 1, what you are supposed to do is minus, somewhere it's wrong. Okay, wait. Minus n I'm having. If you need to find out your value of x bar n plus 1, what you are supposed to do is, yeah, correct. One minute. I need to take your minus 1 by n common, then this will be dx by x bar n plus 1. Yeah, got it. Wait. We know that this integral is integral of dx by x bar n plus 1. This integral of dx by x bar n plus 1 can't I write this as dt by minus 1, that is minus 1 by n, then divided by this t, that is 1 plus 1 by x bar. Correct or not, people? Am I right? So what I am doing here is just try to follow me very carefully. Okay? So here we know that your dx by x bar n plus 1 is something we are having, and we know that your dt is minus n times of dx by x bar n plus 1, and we are having dx by x bar n plus 1 in this dt itself. Therefore, to get this expression, just take this minus n to this side. This will be dt by minus n, that is minus of dt by n. That n I take outside, I took outside, and minus 1 I took outside. Very simple concept. So now it's very simple. So minus 1 by n times of integral of dt by t ln of t. So minus 1 by n times of ln of t plus some constant, because this is indefinite integration. This will be minus 1 by n times of ln log, both are same, just I can write as log itself. So log of t, what I took for t? I took for t as 1 plus 1 by x bar n, that 1 plus 1 by x bar n I can write as x bar n plus 1 by x bar n, just by taking LCM plus some constant c. We know that the constant here is beta, therefore I will write the constant as beta itself. And don't miss any of the variables, okay? Then that will make you guys in a trouble, okay? So don't ever do this mistake, and don't get misconception about the constant. Here the constant is beta. You may think why c is not a constant. Always you're solving question like that, that's why there will be some misconception. But in JEE they can also ask like this. So don't do any mistake like that. So this is what you will be getting. So now just relate these two expressions, that is a times of log of x bar n plus 1 by x bar n plus some beta. So almost these two expressions are same in sync now, except that a. So therefore a will be minus 1 by n. So that's the answer for the question. So how I am solving this is very simple. Log x bar n plus 1 by x bar n plus 1, that is what I am having, and a constant plus beta. Therefore, of course, your minus 1 by n is the value of a. So that's all of this question. So these two questions are good level of questions, because after solving everything seems easy, but the methodology or the idea to bring it out the answer means a lot, okay? So that's all of this question. I hope you guys enjoy it. Thank you. Make education simple.